Today we'll be talking about section 4.10, which is on writing quadratic functions and models. So today we're going to be given graphs or ordered pairs, and then we're going to have to come up with what is the equation of our quadratic function, given either a graph or some data, things like that. So that is our goal today. We're going to write quadratic functions and models. So in example 1, it says write a quadratic function in vertex form. So if we look at our graph here, we have our vertex at -2, 3, and our graph is going to look like this. So we are going to try to figure out how to write the equation of this, given that we want it in vertex form. So we have the graph, we want to write the equation in vertex form. Well, the first thing we're going to need to do is remember what is vertex form. And there it is. Y equals a times x minus h squared plus k. And remember, the vertex is hk. So what we're going to need in this case is the vertex, which we have right here at -2, 3, and any other point that we're going to use for xy. And it doesn't matter, but let's use this one here. And so it's going to be 0, -1. So we're going to plug in the data, the information that we know. The only thing we're not going to have is a. That's what we're going to have to solve for. So we know that y is -1. We know that x is 0. We know that h is -2. And we know that k is 3. So now we just solve for a. So that's going to be 2 squared, which is 4, plus 3. So we're going to subtract 3 from both sides. We're going to get -4 equals 4a, which means a is going to equal -1. So now we're going to plug in the data that we know. We have that the a value is -1. We have hk right here. And so that's all we need to write our equation. So it's going to be y equals -1 x plus 2 squared plus 3. And there is the equation of our graph on the right in vertex form. So again, remember, we have to know what vertex form is to be able to write it there. And so there's our equation in vertex form. Now, example 2, we're going to do the same type of thing, only we're going to write a quadratic function in intercept form. So we're going to look at the graph over here on the right, and they give us the intercepts. Okay. We don't know what the vertex is in this case, so we're not going to use vertex form. And again, we have to remember what intercept form is. So intercept form is y equals a times x minus p times x minus q. And so we're going to take the intercepts here, and we know that the intercepts are -4 and 0. So then we also have to take one more point, doesn't matter where that point is. And on our graph, it looks like this one is -3, -4.5. Okay, so that's the point that they give us. And we're going to plug our data in. And once again, we're solving for a. That's the only thing that we need. So I know my y value is -4.5. My a is what I'm solving for. X is -3 minus my intercept. I'll go, the first one is -4. And then again, x is -3 minus, and it's going to be 0. So now we're going to simplify this, solve for a, and then plug it back in. So -4.5 equals a times 1 times -3. So this is -3a equals -4.5. We divide both sides by -3. and we get that a is negative 1.5, or positive 1.5. And if we write this as a fraction, that would be 3 halves. So now we're going to use the data that we were given. We found a, and we have the intercepts. So we're going to write our equation. So our equation will be, again, using intercept form, a is 3 halves x plus 4 times x minus 0. And again, you wouldn't need the x minus 0. We could just say x, but there is your equation. And that is an example of how to write an equation in intercept form. Now, when you see a problem like this in the book, and typically the way that we would write this, since that is x minus 0, is going to look like this. And these two are the same thing. Okay. The top way is more simplified, and that's the way that we've seen equations written before. So we've done intercept form, we've done vertex form. Those are the two that are going to be the easiest to do. Example 3 is to write this one in standard form. We're going to write a quadratic function in standard form of the parabolas that pass through these points. They're going to give you 3 points. So now we are going to have to use example 3 to write a system of equations. So we're going to take the first point. We know that standard form is y equals ax squared plus bx plus c. Well, we're going to take the first ordered pair, negative 230, and we're going to plug it in. So we're going to have 30 equals a negative 2 squared plus b negative 2 plus c. And so if we end up simplifying this one, we get 4a plus minus 2b plus c. So here is our first equation. Next, we're going to use the ordered pair 1, 6. So if we use the ordered pair 1, 6, we're going to do the same thing. Plug it into our standard equation, y equals ax squared plus bx plus c. We're going to go 6 equals a times 1 squared plus b times 1 plus c. So our equation is going to be 6 equals a plus b plus c. And then we're going to do the same thing with the third point. So we're going to take 436, and we're going to do the same thing. So 36 equals a times 4 plus b times 4 plus c. So again, we're just replacing the y with the 36 and the x with 4. So this one's going to be 16a plus 4b plus c. And so now we have 3 equations in 3 variables. So what we need to do is take the red, the green, and the blue equations, and we need to solve this system of equations. Well, the easiest one to do is to use that green one. So I'm going to start going with 4a minus 2b plus c, and I'm going to take this one, and I'm going to multiply it by negative 2, actually by negative 1. Not negative c, negative 1. Now, the nice thing about all of these is c is always going to be just c. So we can always just multiply these equations by negative 1 to eliminate the c variable. So if we do that, it's going to be negative a minus b minus c equals negative 6. So we're going to get 3a minus 3b equals 24. Okay, now we're going to use the second equation, or the third equation, 30, and we'll leave them in the same order here. So we're going to have 16a plus 4b plus c equals 36. And again, this time I'm going to take and then multiply this one by negative 1 to get to there. So we're going to have negative a minus b minus c equals negative 6. And again, we're going to add those up. So we're going to get 15a plus 3b equals 30. So now we have two equations in two variables right there. And we need to solve for one of those. Well, if we look at that, if we just bring this one down here, the b's are going to cancel out. So this is 3a minus 3b equals 24. We add those up. We're going to get 18a equals 54. Then our goal is to solve for a. So if we take 54 divided by 18, we're going to get 3. So a is 3. Okay, from here, you're just going to start plugging stuff back in. So we're going to take it and plug it back into one of the equations that we had with the red stars by it, one of these last two equations. And so let's put it into this one. So if we put in a for 3, that's going to be 9. 9 minus 3b equals 24. Negative 3b equals 24 minus 9, 15. And so b equals negative 5. So now we have a and b. So we need to plug it back in to find what c is. Well, the easiest one to do is the middle one, the green equation. So we're going to say 6 equals 3 minus 5 plus c. So 6 equals negative 2 plus c. So c equals 8. All right, so now we have a, we have b, we have c. And so we're going to write our equation. So our equation for this quadratic is going to be y equals, a is 3, so it's going to be 3x squared. B is negative 5, so we're going to have minus 5x. And c is going to be 8. So there is our quadratic equation. Y equals 3x squared minus 5x plus 8. And that is in standard form. So far we've looked at writing equations in vertex form, in intercept form, and in standard form. So what I would like you to do is try one of each one of those. So let's go ahead and do question 1. That's in vertex form. Question 2, or no, question 3 is in intercept form. And then let's do number 6. That one's in standard form. So go ahead and pause the video, and you can hit play when you're ready. Here are your answers for those 3 guided practice questions. Now numbers 1 and 3 are going to go pretty quickly. Writing those in vertex form and intercept form doesn't take too much work. Putting them in standard form, writing your system of equations, that's going to be a little bit more time consuming. But here are your 3 answers. So the next thing we're going to look at is a best fitting quadratic model. And this is a model given by using quadratic regressions on a set of paired data. So that's what we're going to be looking at. So example 4 says we're going to solve a multi-step problem. The drama club at your school sells t-shirts as a fundraiser. The table shows data from the last 4 years for the price charged for t-shirts, X, and the total revenue earned for selling them, Y. Use a graphing calculator to find the best fitting quadratic model for the data. So what we're going to do is I am going to give you your table. All right, and here is the table that we're going to use to put in our data into our graphing calculator. So again, X represents the t-shirts, and Y is how much we earn for selling them. So we're going to go to our graphing calculator. So pull out your graphing calculator, and we're going to put this into our lists. So again, you're going to go to, we'll pull up our graphing calculator here. We're going to go to stats. So you're going to hit your stat button. And again, remember we put it into edit. Well, we have some data here in our lists. So remember, to clear them, we're going to go up to where it's highlighted, hit clear, and then hit enter. That'll get rid of all the data in our tables, or in our lists. And so we're going to clear those, so we have our list clear. Now what we're going to do is go back to that data, and we're going to put those in. So our X values, or our list 1, is going to be 8, 10, 12, and 14. So we're going to put that in as 8, 12, or 10, 12, and 14. So there's list 1. Then we're going to look at the data for the Y value, and that's going to be our list 2. So you're going to put that in. And so list 2 is going to be 1180, 1450, 1675, and 1550. All right, so now what we're looking at here, we have that in our graphing calculator. We're looking for the best fitting quadratic model for this data. Okay, so now we're going to hit on our calculators, we're going to go back to the stat button, and we're going to go over to calculate, just like we did our linear regressions. Now, in this case, we're looking for a quadratic regression, so that's number 5. We have list 1 and list 2, so we're going to down there, and we're going to hit enter to calculate it, and there's our data. So if we look at that, A is negative 24.7. So we're going to say probably approximately negative 25. B is approximately 610. And C is approximately negative 2,134. And so if we write those in, and let's round them to the nearest, let's go to the nearest 10th. All right, so when we come back to here, we're going to write our equation. And again, from your calculator, you're going to get these numbers. Y equals negative 24.7 x squared plus 609.9x minus 2134.3. So there is our equation in standard form from this data that we have. So again, in this section, we are talking about 3 different things. We're really just writing quadratic equations. We've done it 3 different ways, using vertex form. So if they give you the vertex of the graph, use vertex form and any other point. Using intercept form, if you know where the intercepts are of the graph, then use the intercepts and one other point. If you just have 3 ordered pairs, you don't have the vertex, you don't have the intercepts, Then you're going to use standard form and write your system of equations. So here is your homework assignment for section 4.10.